Welcome to Screencast 1 for Module 3, Lesson 4, and I am on page 133. So, first of all, they ask you to recall that the domain of a function is the set of input values, or x values, and that the range is the set of corresponding output, or y values. One way to understand a function and its features is to graph it. So you can graph a function by finding ordered pairs that satisfy the function. Okay, so it says to graph the function for the given domain. What are you going to do? What does that mean? Basically, you're going to take your domain, which remember your domain is your x values, and you're going to put your x values in where it says x, and you're going to figure out what y value that generates. Okay? So the first thing you should probably do is solve that equation for y, because that's just going to make your life a lot easier. Okay? Okay, like magic, it's all of a sudden there. So I'm going to take this, which is the function, okay, and we're going to rearrange it. Subtract x, divide by 3, and you finally get y is equal to negative 1/3 x plus 5. Okay? Then what you're going to do is you're going to substitute the given values that they gave you for the domain, substitute those in for x, and figure out what y values that gives you. So that's what we're doing down here. Okay. When the x value is 0, you put it in here, and it generates a y value of 5. So your ordered pair is 0, 5. When your domain or your x value is 3, you put 3 in there where the x was. 3 times negative 1/3 plus 5 gives you 4. Make sure you remember that negative sign right there. Okay, so your second ordered pair is 3, 4. Put a 6 in. 6 times negative 1/3 plus 5. Okay, 6 times negative 1/3 is negative 2. Negative 2 plus 5 is 3. So there is your third ordered pair, 6, 3. 9 is your fourth x value, the fourth item in your domain. Negative 1/3 times 9 is negative 3. Negative 3 plus 5 is 2. So there is your fourth ordered pair. And then it says graph the ordered pairs. So all I do is I take these points and I put them on the graph. Okay, but just like the lovely infomercials, but wait, there's more. So flip the page and join me on page 134. All right, why do you not connect the points of the graph? Well, there were only 4 distinct numbers that made up the domain. So, for instance, points between 0 and 3, domain values between 0 and 3, there weren't any. So we only want those 4 points for the domain and whatever the output or y values that they generate. Okay? So this would be an example of a discrete graph. We only had 4 points. There's nothing to indicate that we should connect them, so we don't, because the range is just 4 distinct set of points, because the domain was 4 distinct numbers. Okay? How would the graph be different if the domain, and I've kind of scribbled and circled, it says if the domain was x is greater than or equal to 0, but x is less than or equal to 9. So, sorry about my scribbling. Here's what it says. Okay, and how on earth do I read that? Well, I just start here. X, the alligator mouth opens to the x, so x is greater than or equal to 0. But then x is also less than or equal to 9. Basically, x runs from 0 all the way up to 9. So if it had been this situation for your domain, that means 0 all the way up to 9 and any number in between. And it could be a fraction of a number, a decimal, or whatever. Okay? If that was the domain, and it was stated this way, then we could connect the points. But remember, the domain was not stated that way. It was 0, 3, 6, 9. Only 4 distinct points. Here, that's anything from 0 to 9. Okay, so I hope you understand the difference. So here, remember the domain that they actually gave us? Which is definitely different than them stating it that way. Okay, and again, just because you guys are not great at cursive sometimes, it says we could connect the points from x equals 0 all the way to x equals 9 because the domain is written to include any number greater than or equal to 0 and less than or equal to 9. Okay, it doesn't have to be a whole number, for instance. All right, go down to explain number 1. And it says if the domain of a function is all real numbers, any number can be used as an input value, producing an infinite number of ordered pairs that satisfy the function. Arrowheads are drawn at both ends of a smooth line or curve to represent the infinite number of ordered pairs. If a domain is not provided, it should be assumed that the domain is all real numbers. Okay? That's important. Okay, so if you are using a domain that's got all real numbers, you're going to use the function, whatever the function, like say we're about to go to this one. So here's our function, y is equal to x squared. Or, if you wrote it in function notation, f of x is equal to x squared. But anyway, use the function to generate ordered pairs by choosing several values of x, and then plot enough points to see what the shape of the graph looks like, and then connect the points with a line or a smooth curve and put arrows on the ends to indicate that it keeps going because the domain is all real numbers. All right, let's see what we have down here. Okay, so they picked enough x values to generate, I don't know, 7 or so ordered pairs so that we could see the shape of the graph that we get. Y'all don't know what it's called yet, but it's called a parabola. It looks kind of like a U, but it gradually keeps getting a little bit further and further apart as you go up. There's 7 points. I drew arrows on the ends because that indicates that it keeps going, because remember, my domain is any real number. That could be any number from 0 on down to negative infinity. It could be any real number from 0 all the way up to positive infinity. It could keep going forever and ever and ever. But anyway, you just pick enough values that you can kind of get an idea because you've picked enough ordered pairs to sort of see the shape of the graph. All right, here we have another example. F of x is equal to 3x minus 5. This time is written in function notation. Remember, it just says f of x instead of y. No domain is stated, so we can assume that it's all real numbers, okay? There are some, for instance, word problems. You'll have to read the word problem to see if like all real numbers makes sense. But if it's just stating like this and there's no word problem associated with it, or there's no real world situation that you're describing, you're just given a function and no domain is stated, well, then you can assume that's all real numbers, okay? So again, we generate enough points, number crunch, put each x value into the function to generate the y value so that we can have an ordered pair. And then we want to plot those points on a graph to see the line. Okay, so in this particular case, it seems to form a straight line. So we're going to connect the points, draw arrows at both ends to indicate that our values keep going in both directions. When graphing a function, does it matter if the function is written in function notation? I said no, just because hopefully y'all understand that f of x equals 3x minus 5 that your dependent variable, your y values are a function of whatever your x values are, or your y is equal to 3x minus 5. Basically, both of them are saying the same thing, so either would be appropriate because they're basically the same. Okay? Okay, so we're going to practice a little bit, and we're going to generate some ordered pairs. Notice on both of these graphs that it's centered on 0, 0. So what I'm going to do is I'm going to pick some x values in the positive territory and pick a couple of x values in the negative territory. Use the function to generate my y values, plot the points, see what kind of function I get. And I'm going to do the same thing over here. A lot of times I'm kind of looking, I'm going to do -2, -1, 0, 1, and 2. So that gives me whatever is going on at the x equals 0 value, -1, -2, so off in this direction, +1, +2 off in this direction, so that I can kind of get a picture. And I think I'll be okay if I do the same thing over here. So y'all take a minute, generate the y values that go with that. Okay, so all I've done, sorry about that, I put my mic down. So all I've done is I have taken each x value, I've put it into the function, done the math, and come up with my y value. So I don't know if I said x or y. Anyway, I've taken my x value, put it in the function, generated my y value. Took my next x value, put it in the function, generated my next y value, etc., so on and so forth. Okay, and once I did that, I have ordered pairs, -2, -4, -1, -1, 0, 0, 1, -1, 2, -4. So I have 5 ordered pairs, and when I plot them and connect the points with a smooth curve, here's what I get. And I also draw arrows to indicate that it can keep going on either side. All right, this other one on number 5, y equals -4x plus 2. Again, we just did -2, -1, 0, 1, and 2 because, you know, we're looking at something that's kind of right around the origin. So when I take -2 and I plug it in, that's -4x, so -4 times -2, plus 2, and I get 10. Put -1 in. -4 times -1 plus 2 is 6. Put a 0 in, put a 1 in, put a 2 in, etc. Make sure I am careful with my positives and negatives, and here's what I get. Because I have 5 ordered pairs, -2, 10, -1, 6, 0, 2, 1, -2, 2, -6. And then you plot them, connect them, put arrows at each end to indicate that they keep going.